Okay, let's see. So we are having a discussion here about types for the compiler and the curation of the types that Wolfram language built-in functions take and return. Is that a fair characterization of what we're doing here?
Yes, yes. So you want to be systematic about this, and actually Jose has some interesting stuff to show as well. So
okay.
And so this is like a kickoff meeting to sort of survey.
Right, and the objective here is to be able to do this both for the compiler, to be able to do your kernel function wrapper for the compiler, right? For compiled code, being able to call into built-in code using this kernel function thing with a type wrapper. Is that correct?
That's one of the goals. But as I point out here, you in some ways you don't really need that's an implementation. And if you want to do, you remember you were talking about verification of Wolfram language code?
I know. I was just beginning my little
right.
Here. Right. So
verifying code doesn't need an implementation.
I'm aware. So I'm just trying to make sure that we have an endpoint in mind here. So the first endpoint is the kernel function callback wrapper, correct?
Right, fine. So different implementations, there's a kernel, kernel function callback to the evaluator.
Mm-hmm.
Okay. And I've listed there's some pros and cons to this. Then there's a link to internal functions.
Right, which goes, yes, we're aware of this, right. And then there's implementation.
Right, fine. And then there's direct implementation.
I don't like it all. Okay, so go back to the first one of those, and let's just look at the issues. Okay. Why is it incurs evaluator overhead? Well, yes. I mean, why?
Because
what aspect of the evaluator? I mean, can't we short circuit some parts of the evaluator once we know that this type of information? Maybe we can't. Well, I don't think
for the actual call itself, it's going through the evaluator. So if it's something that could be done more quickly, etc., that's an issue.
Well, so my question is, what is the evaluator overhead? Because I mean, for example, the evaluation of the arguments to the function will already have been done, correct?
That's correct.
Right. So the evaluator doesn't.
Unless a required kernel function.
Right, but the evaluator then doesn't need to do that. So, for example, in this curation process, knowing that would already have happened in the compiler will be useful because it allows one to short circuit. I mean, basically, the only thing one's going to be doing is calling the down code. There's nothing else. And I would have thought we could have
calling the evaluator because many of these functions have down value implementations as well. I'm not sure there's much to be gained by going straight to the down code. That could be experimented with.
Okay, but so my question is, I mean, we should also know what the overhead is because we might be trying to shoot down what we think is a giant albatross, and actually it's a little tiny sparrow.
Fine, I'm making a note.
Right. What one other kind of con of both these first two, and this is only solvable by implementation in the compiler, is that, I mean, if you're writing compiled code, the only types that you can pass to and from, basically the kernel, are types that are serializable as expressions, and of course, there's then the serialization cost.
Correct.
Right. So I mean, if you have some weird kind of type that only lives in the compiler, which maybe the goal should be that no such types exist, but all types can be serialized as expressions in some way or another. But if you have some weird unserializable thing, then then
you're out of luck. I mean, but the only way the ultimate way to do this is to go directly, for crunchy algorithmic functions, is to go directly to to an internal crunchy algorithmic, endpoint, and bypass all of the kind of fluff code that deals with kind of expression level stuff, because that will be handled somewhere different. But, that's a very complicated implementation effort. That's a long-term thing. So,
I mean, yes, that's needs.
So we shouldn't go there. We shouldn't go there. What we should do is the kernel function thing is the primary target. And, you know, it's worth talking to, and it's a complicated project management effort. You know, people in different kernel development groups who might have structured their code so that this call to an internal function is possible. Am I making sense?
It's possible, yes.
No. I want a little bit more understanding what I'm saying here. I don't
well, what
know.
you're saying is talking to internal groups might find that they wrote a specialized function that could be called directly from the compiler, and that is true.
Yes, right. So, I mean, we might find that, like, I assume Rob Knapp isn't in this meeting. Right?
There are many problems to that, because what's going to happen is the next version, the internal group will have rewritten that function to work in a different way.
Well, no,
because they weren't expecting it to be called.
Hold on,
Tom. Outside.
Okay, everything has problems. We need to find a solution.
Sure. Yeah. Fine. Right.
So what's being done? What we're talking about here is, if it so happens that a bunch of implementation has been done, so there is a fairly clean, essentially C-level or something API layer, then we should find that out. And maybe for the optimization code, that's been done, or the graph theory code, that's been done. I don't know, but let's find out, because.
Well, but either way, I think that, again, we still don't really know what the benefit is of doing that versus just a straight kernel function through the evaluator.
We don't. So I agree.
The kernel function is definitely, and also the kernel functions, like, in terms of implementation, even right now, it's trivial. Like, if you have the type signature,
great,
it's a one-line thing to define it, so it can be used in the compiler.
That's exactly what we want. And you know, the strategy that we should have, and we're not, you know, this is how we deliver something now rather than a decade from now, is what we've talked about many times, which is everything compiles, in quotes. It may just be a bunch of kernel function calls. And that's, you know,
right. Yeah. So I mean, I think, yes. I think that should be the target. I mean, I don't see why. I mean, okay, also, I mean, for the purpose of this meeting, I'm not sure the implementation details.
No, I'm just trying to make sure that we actually have an endpoint and that we know what we're tagging. So, I mean, that's a project management thing, to go and ask people to define what it is we would need from the internal functions, and then find out if it's there. All right, and we're not even going to talk about implementation in the compiler, because that's just a, you know, that's like re-implement the whole system. So let's not even go there. Okay, so the primary thing we're looking at is the kernel function approach. Okay, so now keep going.
Yes, fine.
And wait a minute. We're talking about objectives. So another objective is for code assistance, presumably. I mean, this is something that can be used.
That's what this is supposed to mean.
Yes, but in particular, that means that layers of the compiler. I mean, is there an API? Is there an interface to the compiler? Yeah, we talked about this tag it with types thing, right? Tom, we talked about that, right? Yes,
we did. Yes.
Okay.
That could be.
Let's define our objectives here. Okay. So one objective is function compile can compile almost anything, but often spraying kernel function stuff in it. Right. That's objective one. Do we agree? Tom, do we agree about that objective?
Yeah. Yes. I'm writing down because it's okay. Right.
Well, we have Aubrey here who should be able to.
Fine. Well, I like to make notes as well.
Okay. Sorry, I wasn't paying attention to this. Yes. Okay.
You don't usually complain when people make notes, right?
No, I don't. I'm sorry. I just wasn't looking at.
Yeah. No, that's all fine.
All right. Okay. Right. So now, okay. Second point here. Yeah, I think that the initial objective should be, given a piece of code, be able to annotate it with type hints as far as it can. Does that make sense?
Well, I think if it can be typed, then it can be given type hints. Yes.
But I'm not sure what you mean. Do you mean just like, run the type inferencer on it and then just spray type hint at every level until
that's what I'm
I think that's what it means.
maybe with better UX. I mean, you mouse over and it tells you the type.
Right, exactly. But I mean, but now let's look at what that means in terms of because what that's going to tell one is there are type mismatches. In the case where it's linting code and saying, "Oops, there's a type mismatch here," right? So that will be an objective for that part. Mark up code with trees with type hints, and be able to notice that there are places where you could not find
the type up will be incomplete, because if it meets an inconsistency, then it's going to stop at that point.
Okay, but that's exactly where we have to sound the alarm bells.
Yeah, fine, right. I'm just saying it won't be a complete markup. Yeah.
Well, I understand that, but it could be the case that in a piece of code, hypothesis, right, that given a piece of code, and you want to say, where are the bugs in my code? Okay. It is a possible hypothesis that any place where the type inferencer cannot successfully inference is a potential bug.
Correct. That's correct.
I mean, that might not be right, because it could be that there are enough things that are like your own custom, head-based, expression-based structure that we can't do ordinary type inference. But
yes. But that's why we have things like type hint, you see.
Yeah, I understand, but I'm still trying to think, what are the rules in the code assistance system? Okay, so I'm just trying to understand. Let's take the example of the famous example of plot sin x, comma x. Okay, and whether the type inferencer would how it would deal with that.
You mean that?
Yeah, for example, that.
There needs to be a list around the second part.
I know, but that's the whole point.
I see.
The whole point.
Okay.
It's an error. So, I mean, the question is, what I want to know is, where do we pick up that error? Okay, is that a type error, or is that a completely different kind of error that has nothing to do with this subsystem?
Well, this would say there's no, I mean, obviously, we'd have to have a way to represent this thing here as a type.
Well, yeah.
I mean, we'd have to think, what is the type?
No, but I don't know.
Could say,
right. Okay, to answer the question though, I mean, it depends on sort of the order of things. I mean, I think it could be a type error, if nothing else, from the fact that it has the wrong number of arguments, and that the later arguments are clearly not options.
Yeah.
I mean, in terms of encoding this in the type system, this is honestly one of the harder examples, because there's lots of options, and options are, right now, there isn't really a good way of doing options.
Maybe we should have a type for options.
We could have a type for basically like an option.
I think we can have types options with the sequence thing, Christopher. So
okay, fine. The other thing is that right now there isn't a great way of encoding the types of like symbolic math stuff. I mean, stuff that's basically going to be unevaluated.
Right.
I mean, or at least there's not good ways of compiling it. Maybe there are fine ways of representing the types.
Well, that will be, but okay. My point is, we need a plan that involves getting code assistance that tells somebody this is probably wrong. And we have been blocking on the code assistance stuff on the grounds that, that needs a type system. Now, maybe this one doesn't. Maybe this is a different path with different, code assistance rules. Can you give an example? Can you give kind of a type specimen? And I meant that, sorry, I couldn't resist the joke. Never mind. A type specimen, like those things that go in, formaldehyde jars and so on, to prove that a member of the species actually exists. That's an instance of a type. Never mind.
Right.
But
you want to see an example of like a piece of code and the types for it.
Yes, and the types where in fact one could detect bugs by doing type inference.
Right. Well, here might be a nice example. So if you could write this, Tom. So there's I mean, when I was
do you want to type, Christopher? Do you want to? Should I let you share? Because I'll keep taking notes.
Sure. I guess I could quickly share.
I think you should share, Christopher, if you don't mind, because you're.
Yeah, fine.
But I'll keep taking notes and things.
Okay, so here's let me see. This is a different notebook, but right. So for example, tell me if actually let me make the font a bit bigger. So right. So for example, you could have something like
appending to a integer.
Appending to integer would be a fine one, but I'm going to do a slightly more complicated one, right? So
Sure.
Find shortest tour of, graph of, I don't know, or maybe I should do, yeah, something like this, right? So, okay, so basically we're going to have, this is going to have, I'm just going to write type hint in a million places so that we can see what this is. So this will be something like an, edge of integers, this graph will be a, this list will be a, a list of edges of integers. This whole graph will be probably just
How do you like the colon bracket notation? Is that working out okay?
Yeah, I think it works pretty well. Like I haven't had any problems with it, certainly.
But you actually use it?
Yeah, I always use it. Yes.
Right. Okay. Mm-hmm.
Right. So and then find shortest tour. Let's say this returns the type. It takes a graph and returns a tentatively named list tuple of a real and then a. So to make this make sense, let me run this so that people can see what it does. Oh, well, it actually doesn't work.
There isn't it?
Oh, because I'm honestly not totally sure why that doesn't work. Well, if I give it 3 to 1, it should work, right? There we go. Okay, right. So it gives the length of the path, and then it gives the sequence of sequence of points, right? So the point would be something like, and there's a lot of complexity in here. Like for example, the fact that I said this is a real when it isn't always in evaluated code, and I'm not sure what we want to do there. But in any case, right. But an example would be then if I say, let's say I say tour equals this, and then I say, well, first if I said tour part 3, I'm in trouble because from the type system this is a length 2 thing. Maybe I'd say something like tour part 2, comma, 1. This only makes sense, or like maybe I'd say, right, this only makes sense if because I said 2. If I said 1, then this would be wrong. Like for example, a common error that I've done is I'll do something like this, where it's like, oh, you didn't realize that it gives the length of the tour in the first argument. Right. So catch that, for example.
Okay.
At compile time, not run time.
Well, at checking time.
At checking time, whether it's compiled or not.
Yeah. Sorry, that's what I mean. At checking time, not running time.
Right, but I mean the workflow that we're imagining here is that we have, as we say, a batch mode of linting and a forensic mode of linting. Am I making sense? I mean, the batch mode is you've got a big blob of code and you go through and just generate a report of all the things that might be wrong. That's case number 1. And case number 2 that we're building out is, given that you say this was the wrong result, and maybe this is in the suggestions bar, maybe it's generated when there's a message generated, then you can go and do forensic linting. Do we all agree about this strategy?
Yeah, I mean, you just mean that yes, sure.
Because we're not doing this by default all the time. It's too expensive, and then when you do forensic linting, then the thing will indicate, then the end point of this, the intermediate stage is putting in type hints, and then the end point of this is some kind of indicator in marked up code of whether there is likely to be a problem. And perhaps there should be a way of getting with mouse overs or whatever they are, an indication of what the actual type hinted code has in it. Does that make sense?
Sure. Yeah.
Okay, so next question.
But my guess is that you're most of the time you're going to only look at, right. You're going to only look at the type when it's wrong.
I know,
like
but
when something is broken.
But so the endpoint, my question is this: the type hinted code. Okay, so I'm just trying to understand the workflow here because it's kind of critical, so we don't waste a bunch of time doing the wrong thing. So one case is we're annotating with types for the sake of finding holes where we think the types mismatch and it's probably a bug in the code. Okay, that's case number one. Case number two is we're type hinting for the sake of feeding the thing into the compiler, and we're realizing there's again a black hole in the type hinting system where the thing couldn't type hint, and that's the thing it can't compile. Is that a fair characterization?
Yeah, although I think the obvious problem is going to be if it says, oh, I couldn't infer the types of this. The question is that because there's a hole in your code, or is it a hole in the type inferencing system? Either because there's something that we're missing and, oh, we just haven't done the curation yet, which is realistically what it would be like, at least initially, or because it's like, well, this is kind of an impossible case. You're saving something to some, it's some undecidable case.
Yeah, right. Okay, fine. But then what we've discussed, Tom, can you speak to this? I mean, what we've discussed is that we get type hints. The automatic type hinter goes as far as it can. And then it says in the pre-compilation mode, it says, oh, I couldn't infer the types for this blob of code. Can you, the user, tell me what these types should be? Is that correct, Tom?
Yeah, I mean, that's I got an update from Noah on this project. I mean, the first version is just to mark up the point in, where the error was, what the thing was that couldn't make progress. Next phase is to say these were the possible choices for the thing. And in particular, in cases where it doesn't know how to move forward because there's inconsistent, multiple choices, not inconsistencies. There's just, it's got more than one path.
So I mean,
and you would get a chance to mark it up to say, hey, actually, I meant, this, not,
So we have candidate UX for this. Is that correct?
I think we're a long way from candidate UX for that. We've got candidate UX for returning the marked up blob showing you where the error is.
No. We're not talking about an error. We're not talking about an error. There's two cases here. We need to distinguish them. One case is forensic markup for the sake of detecting user errors.
In top-level code.
In top-level code. That's case number one. Case number two, you are trying to compile a piece of code.
Yeah, that's what I was talking about.
Okay, but that's not an error. I mean, that's a different
thing. Well, fine.
I
think of it as an error because it means the compiler can't proceed.
Okay, fine. A block, right. It's a blockage of some. Maybe we should.
It's a blockage, a bouchon. So yes, a bouchon.
I don't know what that is. Is that French?
It's a blockage.
No. Oh, okay, fine. But okay. Okay, but let's just distinguish these two cases, right? One is, error inference, user error inference. The other is compiler blockage, and
yes.
The expectation is, in the case of user error, that the person is just going to modify their code. They're going to edit their code, right? And because they made a mistake, okay. In the case of compiler blockage, they are going to add a type hint. That's
maybe there might be other remedies they have as well, but the type hint might be one of them.
Like what?
They might say, "Oh, I can use a slightly different function here," or
fine.
They might.
So they rewrite some code. So one case is they rewrite code, but the simplest case is they add a type hint. The thing says, "I don't know what to do here," and you add a type hint, and then it knows what.
Yes. Yes, that's correct.
Okay, fine. And the UX should basically be something which, I think what it should do roughly is it should say, a bunch of things should turn green or whatever, and because it could do the types, and then other things should turn some other color, and then you go in and you can have a nice UX to just wrap a type hint around the piece of code that didn't that had I don't know, maybe there's some place where a little landing pad where you can just type in the type hint, so to speak, or something like that. Does that sound reasonable?
That sounds reasonable, yes. There's a lot of machinery, front-end machinery, that would need to be built to support that. But yes, that
let's see whether Noah, maybe we can give Noah this fragment of this call, since he isn't here, I think.
He's not here. I did ping him today. He is, aware of this.
Okay, all right. Mark, this is just, Aubrey, can you please mark down this part of the recording, and then Noah can the equivalent of be virtually here. Aubrey?
Yes, I'll mark it down starting at about like 12:40.
Whatever.
And tell Noah if he wants to talk to me about any of this, I can fill him in on details.
Okay. All right. Okay.
That's helpful. Right.
Okay. I think we understand the objectives now, but we got to be very, very clear. The objectives are, in the forensic case, that the thing would basically indicate with some kind of, pink overlay or something, the areas where it thinks there's a problem. I think do we believe that its description of what the problem is will be sentiently understandable to a user, or is it absolutely hopeless?
Do you mean in the context of trying to compile it, or
no?
The
user error. I'm talking the two different cases here.
No, but I'm saying, okay, I think that at least the way the errors are set up right now, although it might be possible to make them better, I think they would be, to the just a totally naive user, they're probably not going to be very comprehensible.
Remember, we're not talking compiler blockage. We're talking user error first to begin with.
Okay, fine.
They wrote a piece of code. They don't know anything about the compiler. They don't care about the compiler. They've never even heard of the compiler. They ran their code. The thing spewed messages. We offered them the alternative, do a forensic analysis of your code.
I see. Yeah, right. Then, yeah, I mean, it's
if they got a message saying find shortest tour returns 2 elements, not 10, they would find that useful.
Yes, they would. But I'm asking you, given all that you have is a black hole in the type hinting system, right? That's all you actually know, probably. Am I correct in the user error detection?
That's not totally true. I mean, usually the type system, it knows more than just that it failed. Right? Like it'll know, I failed to unify these types or something
Correct.
like that.
Yes.
And then that gets turned into slightly more.
Okay, but hold on. What we're trying to do is write a function that returns a symbolic expression that is festooned with type hints. Okay? Now, if the thing comes to an end and it cannot generate a type hint, maybe it needs another symbolic indicator of what went wrong, a kind of type failure object.
Right, but the point is, it's not going to annotate. If it can't annotate all of them, it's not going to annotate any of them. That makes sense. Like either it finds a solution to everything, or it's going to say, I failed, and this is a description of how I failed.
But Christopher, actually, it does have information going forwards up to the point of failure. So there is some information there.
But it will have like type variables in it and stuff like that, won't it?
Well, no. It'll have total type solutions. It depends a little bit how.
Okay, wait a minute. We need to be clear about this because this will blow up the whole idea. If what you're saying is right, basically in the compiler blockage case, I was assuming that many type hints will actually be there, and that there will simply be this black hole area which is missing type hints, where it basically got stuck because it doesn't know what the type of this particular thing is. Am I right about that? Or are you saying that if it doesn't know what the type of a particular thing is, it cannot annotate anything with type hints?
That's not true.
Which is not true?
The last thing you said is not true. It does know things about, it does depend a little bit on some of the details, but the type inferencer tries to work in a forward mode. It's a global inferencer, so it's quite possible to work code that has to go backwards or sideways or whatever.
Fine, but then the end result here is, it has been my theory that the thing that we need a function, the modular function that we need, is a thing that takes a piece of code and annotates it with type hints, and that thing would be the thing which then goes down the line and says, now I'll
experiment with writing something like that.
Well, I thought you said that like a month ago, but okay, fine. Well,
No,
okay.
no. What I said, well, fine.
Okay.
But so the idea though is just to have it something like you have this piece of code, or maybe you have, this piece of code, and it just, highlights some part of this, I don't know exactly what, UX question in red, and it says, here's your problem.
Okay, but wait a second. We've got two different types of problems, and we really need to distinguish.
I know we're talking about this. We're talking about the first problem. We're talking about not compiler blockage.
Okay.
Although
all right.
realistically, the compiler blockage will have the same UX because it's using the same type inferencer, and it has exactly the same information, but what went wrong. So they're not actually that different.
The remedy is different because in the compiler blockage case, the likely remedy is add a type hint. Whereas in the user error case, the likely remedy is edit your code.
I'm not, maybe. I'm not sure about that. I mean, because the basic point is that the things that the type inferencer will be able, the things that the type inferencer will be able to reason about is exactly the same as the things that can be compiled.
That's correct.
I mean, of course, they might be compiled full of kernel functions, but the point is that it's not like, if you have an error in code that you're trying to compile, this is going to be the same sort of error that you're going to have if you were writing code just in the top level.
No, okay.
Let me see. The probability that the problem is fundamentally the type inferencer being dumb versus you being dumb. Those, the prior probabilities of those are the same whether you're writing it in compiled code or in top level code.
I'm confused here. Okay, let me see if I understand. Okay, so there is a long transient period where we will not have completed the type curation process.
Yes.
Okay, point one. Point two, there are places where it's kind of undecidable what type it is, and where really it's a question of the user says, well, in my code, this is supposed to be a list of integers. Oh, if it's not, you can generate an exception. But to know that it's supposed to be a list of integers, you'd have to solve the Riemann hypothesis to know that this is always a list of integers. But you're prepared to go out on a limb and say, I, the user, think this is always a list of integers. Therefore, I will add a type hint to say it's a list of integers. And,
yes.
Okay, so that case seems to me that the way forward, in the case where it says, I've annotated up to this point, and here, all I could do is put this as a big blob of kernel function, a big arbitrary expression thing, which will then infect the whole rest of what I'm compiling, and I won't be able to compile anything here. But
I don't think so. I mean, that last part I don't think is true. I mean, the whole point about having type annotations is that you don't have to infect things because hey, this took an integer-like expression or something like that. It's going to return another integer-like expression.
But it could also be the case that thing that you, the user, know is a list of integers, that going outward from that, a ton of stuff would have resolved types.
Sure. Like if you mean if I annotated something that was missing, it might be able to figure out a whole bunch of stuff. Yeah, sure.
Yes. But I mean, but so the UX would likely be, let's say that, I don't know what it might be. It's some kind of number theory. Let's say that you've got a bunch of number theory functions which take integers, return integers, et cetera, et cetera, et cetera. But they are a big nest of number theory functions is wrapped around a thing called list. And that thing called list is of unknown type.
Right. Now, so I have, list factorial. And I want to say, by the way, this list thing that you don't know about is a,
Exactly. Right. But it might encrust, that list factorial might have a big outer, thing of 7 layers of number theory functions.
Sure.
And they all would say, I don't know what to do, because they're all, so that's a different question, it seems to me, is could we do an analysis, given that, of these are the kind of, the critical points, where if you could only annotate this type, then you could trickle down and get all kinds of information. Is that plausible? In other words, what is the dependence of,
Well, you could know, like you've got your function factorial there. You could know what possible functions there are for factorial.
Possible types, you mean?
So sorry, you know what what function, what types you have for factorial. So you could say, hey, if you make, this could be this could be a list of integers, and that's
I know that, Tom. I know that. What I'm asking is a different question. You've got something here where let's say that list was the result of, I don't know, something about chemical elements. Okay, so it's not just list which is coming from the outside. It's a thing where we could know the types. And by the way, I don't know if you're planning type annotation for entity property things, but that's another interesting thing to think about.
Sure.
But my question is, so in other words, it's a pure internal game. That list thing is something purely internal. And in principle, if we'd annotated everything, if we curated everything, we would know the types here. But my question is, in a situation like that, do we have any chance to be able to say, this is the pivot point?
Yes.
Go annotate this type, and then everything else will flow from it.
Right. So the two cases you mean would be something like this, where it's like, well, the critical thing is you know what list is.
Yep.
The other case would be something like this, where we don't know the type of Euler phi. We know all the other ones, but we don't know Euler phi. And so the critical thing is we need to know the type of this. Right. I think in both of those cases, even just the way the existing type inferencing stuff works, I mean, those are the two places that'll give you the error. It'll either say, I don't know the type of list, or it'll say, I don't know the type, or I can't find a definition of Euler phi that takes a list vector machine integers.
In the compiler blockage case, the UX that we expect is it will be something where there'll be stuff that's in green that has been type hinted, and there'll be stuff that's in pink or whatever that hasn't been, and where you basically go in, you mouse over the pink stuff, and it gives you a little thing that says add a type hint here, and then maybe it gives you a hint for the hints later.
Right. Although, I mean, this is kind of a minor point. I'm not sure the extent to which there'll be things in green, because there'll be stuff where, well, maybe Tom can comment on this. There'll be stuff where you haven't really reached it because there's.
Well, there might be a subtree. You might have a list of 3 elements, and 2 of them.
Christopher, there's a point at which you have list equal. I mean, there's somewhere where the list is being introduced, and it's either coming from an assignment or it's an argument from a function. Okay.
Yeah, but
sure, yeah.
But
that's the point at which it would, that would be a useful point to say, hey, here's the problem.
Sure, but the case where of things turning green is you've got a list of 3 elements. One of them has unresolved types. The other 2 are fully resolved and are both known to be returning, integers or something. Right? So those 2 could go green. Am I right?
Yes.
So a subtree could go green, but then there's a part that will be infected.
Yes. I think all these things are possible. It's a global inferencer. So, of course, if those subtrees have, it'll carry around those alternatives depending upon the last unresolved thing.
All right. But anyway, the most important thing for the blockage case is to annotate, is to, pink up, so to speak, the place where the thing got stuck.
Exactly.
Right.
The other stuff.
But also, just to be clear, I mean, this is the same as the checking evaluated code case.
You mean it's going to pink it in the same places?
I mean, yes. Maybe the UX could be different, but realistically, it's going to have exactly the same information. It might as well pink things up in the same way.
Oh, that's fine. But I mean, but the remedy is different.
Why? I don't think it is.
Because yes, the remedy in the compiler blockage case could be purely add a type hint.
Right, but okay, so we're talking about, there's some probability the problem is add a type hint, and there's some probability it's you made a mistake.
Yeah, I agree. Right? But
the point is that I think those probabilities are the same in compiled versus sort of checked evaluated code.
No, but look. Okay, I don't understand. There's no point. Okay, in the case where we are merely using this for forensic error detection, nobody cares about the compiler in that case. They're just using it.
But the type system will. I mean, okay, if what you're saying is basically that if the I think I understand the confusion. So I think what you're saying is that in the checking top level code case, if it says, oh, I don't know anything about Euler phi, it will assume all is good. And it will say, I don't see any problem there because I don't know anything about it. As opposed to the compiled case where obviously it's going to complain because it needs to actually compile it. So it's,
Yeah, that would be one.
And so, right, but my point is, I don't think I'm not sure that's coherent because, the type system really doesn't know the difference between, oh, I don't know about Euler phi, so I can't comment about whether it's correct, and, oh, you're doing the wrong thing here because Euler phi doesn't exist, or,
okay, look, the point is, in code that has nothing to do with the compiler, it seems implausible that people are going to spray type hints into it. Our system will spray type hints as a way to get it's a heuristic way. I mean, and those type hints might flow through code assistance rules.
I'm not sure what you mean by spray. I mean, are you talking about spraying type hints as an implementation detail?
No, yes, I'm saying what I'm imagining is that in the case where we're doing forensic error detection of user errors, right? Forensic error detection, the thing spewed error messages, you say, give me some idea what you think is wrong. Okay, then what I'm imagining the implementation of that is first it goes through and annotates with type hints. Then the code assistance rules look at those type hints as to give them a leg up on what's plausible and what's not. And the code assistance rules then report on things they think are wrong.
Possibly. So even if the type system fails, so even if the type system says, oh, this looks wrong, it's still up to the code assisted system whether it wants to take that into account and trust it?
Perhaps, yes. I mean, I don't know. We have to try this. It could be that it is a, look, it's like the statement, if your code looks really ugly, it's quite possible that it's wrong. It has some weird extra case. It's quite possible that case is wrong because that's just the way the language design works. So similarly here, it could be the case, and I don't know because we don't have experience with it, that as soon as there's a type, inability to annotate types, that's a place where there's likely to be an error. I don't know if that's a user level heuristic. Right? I don't think we know. And I think all I'm suggesting is that the expected workflow is we surface the type hints so that when we make rules, because, if you look at the code assistance rules right now, there are a bunch of things that say, duplicate case in a switch, something like that. Okay. But
sure.
There are more types of rules that you can write if you have type hints.
I guess so. Okay, fine. Sure. Right. And so it's sort of I think this is kind of I'm not sure exactly what rules the type hints will help with and what, the point is that if we're talking about the case where the code doesn't compile, in other words, the type inferencer can't infer the whole thing. The question is there still useful information in the type hints?
Well, okay, so a million times
could use.
with Brenton, as we've been going through code assistance stuff, he said, oh, I can't make a rule for that. I would have to know the types.
Sure.
Okay. So my assertion is that if you knew the types, then you could make a bunch of rules.
What he's talking about there is things like flowing value, types through variables. So you have module, X equals something, and then a bit later you have, something where if it was all literally in one place, he could tell it, but he could give a useful thing, but he couldn't follow it through the, the flow through variables.
I think it's more than that. I think it's something like, we have to look it up, but there's many, many rules that I proposed where I've been told we can't do that yet because we don't have type inferencing. Okay. So what I'm imagining is that most of the rules operate on a concrete syntax tree and basically are just pattern matching rules that say, if it looks like this, then make this code assistance suggestion. All I'm suggesting is that it operate on a concrete syntax tree with type annotations.
Sure.
Right. Yeah. But it was things like you wanted an error for append 1,5 to be so that
right.
But if you had X equals 1 and then append X, 1, that would right. You see, this was the sort of thing that Brenton found hard. Yes. Correct.
Okay, so fine.
Right.
So let's talk
So,
about how that's achieved now.
Right.
I don't know how important that is, but
It's very important. It's the blocking item for code assistance. Okay.
Fine.
Right now, code assistance is little more than a toy. The cases
I actually disagree with that. I think if you're using it in a text editor and you have the linter running all the time and so on, it actually gives you, quite useful things. I mean, if nothing else, stuff like, there's stuff that you get in that environment like, oh, there's an unused module variable. I mean, that's an example of a super common one.
Right.
No, that's useful.
I
agree.
Or probably a missing semicolon.
Hello. Can I say something?
Yeah.
There's other compiler tools that can help with things like this. There are use-def chains. So you can follow the the definitions of like A and B back to where they're defined. That's also what's quite hard for.
Yeah, that's useful. That's definitely useful. But my point is this: I think
without type, you don't need type inferencing for that.
Okay, all right. But we need a pattern for something where we take the concrete syntax tree, which is presumably the thing on which the code assistance rules are being applied, and we annotate it using whatever we can annotate from the early passes of the compiler. So you're telling me that there's this use-def thing is a different annotation, but the whole point is we just need a framework for doing annotation from compiler technology in the context syntax tree. And the end result, there should be a function that basically just says, annotate this concrete syntax tree. First, given an expression, an evaluated expression, generate the concrete syntax tree without annotation. Second, take the concrete syntax tree, or I don't know whether it does both at the same time, and produce annotations based on these parts of the compiler pieces of compiler technology. Does that make sense?
I think so. Yeah.
Yeah.
Okay.
Yeah.
So in the case of this append example, would the type inferencer be the thing? What would it do? And would it complain?
It doesn't need type inferencing for this. Well,
it does. Append needs to know, right? Yeah. I mean, so here's the thing, right? I mean, this makes some sense. The question is, we're basically saying the type inferencer won't be able to infer everything, but it'll be infer some things, and maybe the code assistant stuff can use what it can infer. So basically, what we're talking about is the code assistant thing is going to use a somewhat unreliable type inferencer in the sense that if it inferred something, you can maybe trust it, but if it couldn't, you don't know anything. So in this case, for example, if it said, oh, well, I know various definitions of append. I don't know any definition of append that takes an integer in its first argument, right?
Right.
Does the code assistant system trust that?
Yeah, right. Well, that's it.
In the case of append, it probably does. In the case of something else, I'm not sure it does.
Right, but that's up to it to generate. That's why it has a layer of rules on top of this annotation. The annotation is merely just like the concrete syntax tree is, kind of this is what you're dealing with. And then, for example.
No, sure. All I'm saying is that I think we need to think about the type inferencer will be unreliable in one way or the other. Right. Mm-hmm. And we just need to think about what is the useful thing to give to the code assistant stuff so that it can actually have rules. So it's not just like, oh, well, I have this piece of information, but if it tells me it can't infer it, that means nothing. And if it tells me it can, that also means nothing. And so it's useless.
Yeah, exactly. We
need
to know what annotations are, and whether it needs annotation confidence or whether it needs a definitive, I don't know. Okay, so that's case number one. So we need to actually figure out because I think it's the very important thing that I keep on emphasizing is, rather than this being somewhere in the innards of the code assistant system, I think we need a pipeline where we actually return a symbolic annotated thing, which then we can operate on with rules. Do people agree about that?
You mean similar to how the code, parser returns a concrete syntax tree?
Yes, that's right. Yes.
I mean, I think that probably is just, I think the concrete syntax tree has all sorts of generic ways of annotating it. So it's probably just a concrete syntax tree object.
Yeah, I think that's fine. But I'm just saying it's got to be returnable as something where, for example, people could write WFR functions that operate on that and experiment with lots of different ways to do particularly batch linting. Am I making sense?
Mm-hmm. Yeah, sure.
Okay, all right. So now, just to make sure I understand, in the case of compiler blockage, what you guys are confident that you can basically indicate in sort of pink where the compiler got stuck, where the type inferencer got stuck, and that you click on the pink and it gives you this thing that says you can add a hint here. Here are potentially some hints for the hints. Are we in sync on this?
I'm not sure that you can add a hint here.
Yeah. I mean, you can mark up points where it got.
No. I'm saying the UX, in the end, would be you see a copy of your code. The code has pink points in it. Okay, which are the places where the type inferencer got stuck. Okay, at that pink point, like that list case we just did above, you could add something that is a wrapper, a type hint around the list that then would resolve that pink point.
Okay, but the point is that it's not. So, okay, a couple things. The first thing is that this case where you need to annotate this this would never work because this needs to be defined somewhere, right? And normally it'll be wherever it's defined, we'll make it clear what its type is. Yeah. The case there are two cases here. There's the case of this thing basically can't compile the way you've written it because the types just don't work, right, for the purposes of the compiler. And then there's the case of, there were a couple options and it couldn't really figure out what was going on because it couldn't tell what kind of list you meant or something like that. Right. The first case, first of all, the first case I think is much more common. Like more often it's
it won't be common in the early stages of curation because there'll be tons of stuff where we simply missed it.
Right. But then right. There are also some cases where it's sort of like I'm not sure these are all going to live forever, but there are some cases where it's sort of like this is something where the types, like okay, if you have right now, like if you have an if statement that has different types in the true and false branches, right? I mean, if we have union types and so on, maybe we can just represent that it's not an error. But right now it is an error, right? Okay. But that's not something where it's a matter of it's not a matter of, we're just missing that functionality in the compiler. I mean, maybe we should eventually, but you know what I mean? And the other, no type hint will save you.
Okay, but then that's okay, fine. Then that's a case where we've got to say this code. Well, it's not a question. Okay.
I mean, I think telling people, look, this is just a matter of like the compilation failed. Give a reasonable message about what happened.
Well, right? Not just a message.
And whether that message, it shouldn't tell you, write a type hint that says this.
Okay.
If it could do that, it wouldn't be an error.
I get your point. But okay, the most important thing is you got a big blob of code, and rather than just saying, I can't compile the whole thing, goodbye. What we're looking for is something where there are small pink points within that code where you can scratch your head and say, well, can I resolve this pink point? I had thought, you resolve it with type hints. You're saying there are cases where type hints are not enough.
There's other remedies.
Okay, and you have to rewrite the code, basically. What other remedies are there other than you rewrite the code?
I mean, I think that's just all the standard remedies of your code doesn't work.
No, right? I know, but it's not a question of doesn't work. It's the compiler couldn't compile it, and that's our fault.
No, sure. But the solution, I think the solution is either going to be, it's just the type inferencer got confused, but fundamentally the functionality exists to compile this, in which case, yes, it is a matter of adding a type hint.
Yep.
And then there's the case of the functionality doesn't exist.
Right.
And so the way you've written it, this just can't work.
Right.
In which case, you
have to rewrite it.
You have to rewrite it. Yes.
Yeah, that's fine. Or you just have a big blob of code that is, let me ask you this. Could one just have it be the case that this piece of code will not be compiled, this inner piece of code won't be compiled, but on its way out, you're casting the result into something which is of a particular type? Is that a feasible remedy?
I think so. Yeah. We talked about, I forget if we talked with you. Tom and I have talked a little bit about having something like that. It's a little bit related to this if compiled, a little bit related to this if compiled thing. But right, the idea, Right. I mean, there's some slightly complicated stuff about, well, you have this evaluated section, there are maybe compiled variables that need to be used in the evaluated section, stuff like that. But I think ultimately that could be doable.
All right. Let's turn to the actual supposed topic of this meeting, which is the curation of types. So I think we now understand what these are going to be used for. So let's take a look at what the ideas are for the actual curation process.
There's actually one more useful piece of information that we might want to gather, and that is to know whether functions that operate on lists can be parallelized or not. Like things like map.
Things like side effects, for example.
Yeah, I mean map and select can work independently on sub-pieces of the input, but fold list or nest list cannot. So this
Right.
kind of information would be useful to have.
Well, but so this is also inside parallelize. One could imagine a pinking approach that shows what things inside parallelize won't parallelize and which will. Is that right?
Yes, I mean we've discussed that in ECE, and that is supposed to be a meeting about that with a front end team, I assume.
Okay, fine. But that's another pattern, maybe different from the compiler, of just you've got code and it's rewritten it inside parallelize, and it's at the user assistance level, it is coloring things. But okay.
There must be other cases like that.
Well, but you're basically saying in the concrete syntax tree, in addition to these, whatever you're calling them, USTEF chains, there's also side effect wrappers saying this is side effect free, this is pure code, et cetera, et cetera, et cetera. Am I correct? So those are additional annotations that you should be able to request when the concrete syntax tree is being generated. Does that make sense?
Yeah, I think so, yeah.
Christopher, does that make sense to you?
Yeah, I sure, yes. I think some of that will probably, well, yeah.
I mean, but we're just concentrating the sort of symbolic effort into a very annotated concrete syntax tree. And then we know sort of what the output is supposed to be. All right, let's go back to the original topic here.
Yeah. Well, Tom, do you have more stuff in that notebook, or?
No, I think that notebook's finished. But Jose has some interesting stuff, by the way.
But let's look at. You seem to have an agenda here, so why don't we look at it?
Well, I just have a few things. I mean, so right. So I mean, I did sort of I spent some time. I took a bunch of list of symbols sorted by frequency according to Wolfram language data, which honestly was not the best way to do this. But I took a bunch of symbols and I sort of categorized them based on these four things. So basically, things that already compile, like map, things that are quote unquote currently uncompilable. So that usually meant like options and stuff like that, where it's sort of like this is just a piece of the language that isn't really supported in the compiler. Kernel functions, this would be things like find shortest tour, and then re-implemented. This usually was things that were either, things like map indexed, where it's like, that should really, it's not that hard. And it's also the sort of thing that's one of the sorts of things that really should be compiled, or it's something where it's like super trivial. It's just a compiled expression declaration. For example, something like RGB color for the most part could just is just trivially compilable. Right. Okay. I also, many things were flagged with multiple ones, like RGB color had both 3 and 4, for example. So, right. So maybe first, these are some of the results. So I looked at, I don't know, however many, couple hundred functions or something. So, right. So, I mean, the biggest, again, this is a bit of a weird set because it's these very common functions. So things like, lift and plus are kind of a lot of them. Yep. But, right. But I mean, the point is there are a lot of kernel functions. There are a good number of re-implementations, but a lot of these I tagged as both kernel function and re-implementation because basically, the core of it would probably be, a kernel function. All the complicated stuff would be in a kernel function. And then most of this is like options and things. So actually, I think I have a visualization. This is a little bit broken with this width, but yeah, I mean, so you can see sort of for some of these different things, how they categorized.
And Interesting. Okay.
But yeah, I mean, of these very popular, and this is very rough. I mean, I spent
so there's a lot of
1
red.
second on each of these.
There's a lot of red. So those
Yes.
which would be successfully, in other words, this project of annotating things that become kernel functions makes sense.
I think so. Yes. Yes.
Right. Okay. And the re-implementation is so, doing that. So that again, you think those are fairly straightforward re-implementations?
Most of them, yeah. I mean, the ones that are only tagged as re-implementation are usually simple. But
like $failed.
$failed is a trivial re-implementation, and there's so many purely compiled functions that need to be able to return a $failed. So it needs to be kind of re-implemented. Like the right way to do is to re-implement.
Right.
Right.
Okay.
The other thing I listed for the purpose of this,
yeah,
that I listed as unsupported would be math functions, or functions that have symbolic math objects, like integrate or something. But that might be, resolvable.
Right. But this thing about wrapping, look, let's say you have a definite integral, hopelessly uncompilable inside, but the result is a number.
Yes.
So with a cost, you could actually have that be part of a compiled code.
Right. Or if you had one of these, whatever you want to call it, uncompiled section. I mean, that's not the name, but right. So if my compiled code is 2 plus uncompiled section of integrate of whatever, right? I mean, this.
But isn't that kernel function, Christopher?
No.
Well, it's very similar to kernel function, and it might be, in terms of implementation, it might be basically the same. So you can already write this as kernel function by writing something like, you could certainly write, that, but you don't want to.
But you want to pass arguments into it.
Sometimes you do, and sometimes you don't. And also maybe you want to be able to automatically pass arguments. So if I say type of arg, comma, machine integer, I want to be able to say, arg plus x, right?
Yep.
But if you're writing that, it's different from kernel function.
Sure. Yeah. I mean, I think that this would actually be quite a useful thing to have.
Fine. So it's like a kernel function which has things passable into it.
It's like automatic binding. So.
All right. Okay. So let's come back to the actual. All right. So I would have thought that it's worth distinguishing already compiles from not applicable, because I think we could imagine in documentation putting a little flag for when things compile.
Yeah. Although the only somewhat difficult thing with that is there are a lot of things. Well, there are a lot of things that at least should only partially compile, where it's like, well, we compile the main usage or the main two usages, but we don't do all the options, right?
All right. So can we start looking now at what, in the case where one is trying to annotate? So re-implementation, it's just going to be something that is part of the compiler, essentially part of the runtime library in effect.
Right. I mean, it's just some core thing.
Yep. Right. Okay. So let's look at the ones that are kernel function.
I think I have a way of, oh, maybe I lost it. Oh, no, it's this. I had a way of organizing it. There we go. Right. So now it's by category. There were some of these, though, that I just noticed that looked, I'm not sure if I generated this the right way, because there was some, like, I saw, plot range that I saw re-implementation, but it shouldn't be, or like plot style, that's an option, but okay. Yeah, in any case.
I do think there's some general thing that should be done for options, but that's a different story. Okay, let's look at the ones where
I agree.
The most important stuff that is, the stuff that is like, random list manipulation-y functional programming code. That's the stuff that seems to me the most important to put in this kernel function wrapper or do the re-implementation things so that we can just make any of that type of code compile, because that's the stuff that it's going to have the highest leverage. That's the place where
and most of that does compile, The cases that don't are almost all associations.
Okay, but
which is the thing that needs to compile, right?
In the wild, okay, well, I don't know what's happening with that, but in the wild, I've never been able to get things to compile. I mean, I've never actually had an example where a piece of in the wild, not particularly fancily written list manipulation code actually compiles.
Right, but usually it's because there's an association in it. Like I've had a similar experience. I have had a few things that have just in the wild compiled, but they're almost always things that were purely dealing with lists that know.
So what is the story of implementing associations?
Well, okay.
Go ahead.
The basic, Tom can probably say more about this than me. I believe that we should basically just make a version of, make an association type, realistically 2 association types, association vector and tuple, in the same way that we have list vector and list tuple. And we should just do it using basically the hash table type.
No, I think that's a bad idea. I think we're better to wrap the association expression. Hash tables are immutable. You'd quickly run into terrible consequences. So
okay, so here's sort of the issue, right? So for lists, right now we have 3.5 things, let's say. So we have list vector and list tuple. Let's forget about the tuple types. Okay, we have list vector, which is basically the native compiler way of representing lists. You can have lists of anything. It doesn't have to be expression serializable or anything like that. Then we have packed arrays, which are kind of the native kernel way of representing certain kinds of lists and arrays. And that has various nice features, like the fact that you can pass it to and from the kernel, for free. There's no conversion that has to happen.
Yep.
So similarly, there's value in having something like the packed array for associations, something that's, it's just the kernel association. You can operate it on the compiler, but you can pass it back and forth easily. But I think it's also, we should make basically, partly because this is easier and it's a thing that we can probably do quicker, which is basically just make the list vector for associations. This is purely in the compiler, and it can serialize and deserialize at will.
With the data container project, we are trying to make essentially an inner version of something like associations. So that's the thing to plug into when it's ready. It's not ready yet. Well, and I also think
that's not exactly the problem, though. The problem has to do with, for example, right? Associations, the way associations work in the kernel, the keys and values are expressions. They're not integers.
I know.
Nothing else, right? So it's like that means, if you're compiling things, you either have to be able to serialize whatever the things are to expressions, or you're toast.
No, but I don't think
in the same way that packed arrays fundamentally, there are only a couple types that packed arrays can have. Right?
I think we should just have a thing. Look, I think that the 90% case is associations whose keys are strings and whose, unfortunately, the types aren't always the same of all the elements. But then the other point is, I think the 90% case is that you're not mutating the association at all. It's just you make it somewhere and then you access pieces of it.
So that means there's no append, there's no replace.
There's no append. No, nothing like that.
Fine. In that case, if it's not mutating it, then it could be a hash table, Christopher.
Well, or it could at least be immutable. I think it should have the same semantics. We should just do the same semantics in the top level, which is if you call append, it'll make a new association. If you call associate to, it'll modify.
But that'll have horribly different behavior from the value.
So don't listen. Most of the time when people use associations, they are not mutating the association.
I dispute that.
I think yes, although in compiled code, I can imagine people doing it more, because one of the reasons they don't do it is because it's usually, if you're writing something that has a loop and it's adding to the association, this is a bad idea. But
no, sorry, that's nonsense. It's a very good idea to add to an association in a loop. It's
in compiled code. I would say, like if you have oftentimes it's more efficient to get all your rules in a row and call merge in the top level than it is to call a loop that's inserting a million times into an association.
That's because that's because loops are slow.
No, exactly. But that's why people use compiler.
Right.
It'd be fine to write it that way. Yeah,
right. Yeah. But so I think the case we should support first, because the first case is people have existing code and they want it to compile, and that case should be immutable associations. And we can clearly detect.
I don't understand what you mean. Associations are immutable. So how? Sorry, I'm
non-modifying associations. Associations where
so you can't modify the association.
That's correct. You generate it.
That's fine. I think we'll quickly find that unsustainable, but fine. That's fine.
But then you detect in the compiler whether it needs to be the other type.
So I'm just kind of confused, though. I mean, isn't this just the same as top level? I mean, if you try and append to it, it'll copy it and then append to the copy, right? I mean,
that's not how association works, Christopher.
Okay. I mean, if you call append, though, and it returns a new association, you still have the old one and you have the new one.
But the append, but it doesn't copy every element, Christopher.
How does it work?
Oh, sure, because I mean, the elements are pointers.
Hugely complicated trie business that shares most of it shared, you see. It's a trie thing.
So you mean when there are two associations, one of them is longer than the other, you're saying if I were to look at the internal memory usage, if I do this in a loop and I append to an association, that the memory usage...
it's going to be a big, hairy trie business.
Wait a second.
Yeah.
It will not be quadratic. Is that what you're
saying? Correct. Absolutely. Surely everybody knows this. I mean, sorry. How can we not know this?
Well, it's brilliant, Tom, but I didn't know it. Okay, so you're saying if we append in a loop, that
we do that, yeah.
Right. So if I do this, and I'm gonna keep the associations around. And then I'll also give the memory in use. And we'll say,
brilliant.
That is a linear line.
Very impressive, Tom.
But this is the value proposition of associations. This is why we freakingly wanted to add them.
I don't think people know this. I didn't know this.
Yeah, well, because we don't tell people anything. Well, okay, fine. There's
tell people anything. It's all secret.
There's a vector. There's a list for. There's a data structure called an immutable vector. That's the same sort of thing, but it's for it has lookup, indexing. So you can append and
This is presumably n log n, not actually linear.
There's a log. There's a log in there. Correct, Dan. Yes. But log is a pretty.
Barely see it.
Right.
Yeah. Correct. It's very
impressive. It's very impressive. Well done.
So look at the So you can append like appending to it is fast. This is like a list, but you can append to it.
All right. This is really wonderful. And actually, this is something people should really know about. And I don't know whether we have, maybe we should have at least workflow documentation about repeated appending to lists or something, or repeated,
Actually, we should have that. So what I would like to do would be to implement association as a data structure, you see. That's what I like.
But Tom, let's deal with the first case, which doesn't use this thing that none of us knew was brilliantly there.
Right.
Okay. Where it's just being used as a receptacle of indexed data. Okay. So let's come back to the question. So I gather there was some other things that Jose had to say about this curation process or something related. Is that correct?
Yeah.
So maybe
Jose had some nice stuff, I thought.
Okay, so maybe Jose should speak because we are running out of time. So
actually, I'm hungry.
Yeah. Can I share for a moment?
Yes, definitely. Oh.
So I have worked in several projects related to types. So I'm going to mention three. So the first one is the predictive interface, where we have like syntactic types. And then something I wanted to mention is that something very useful for us, and I don't, in the predictive interface, and I don't know whether we want it here, is that we have semantic derived types. For example, imagine that we have string lists, so a list of strings. So we separate a list of contexts or a list of directories, because if we know something in a list of context, we can then suggest to use it as a in context path and things like that. So it's very powerful. So this is an idea that we might want to consider in this project. So having
how well built out is this stuff for the predictive interface? I mean, and also, maintaining the predictive interface is non-trivial, and merging these things will be really nice.
Yes. So this project we are talking about here in this meeting is going to be something similar, because we have to go through all the functionality, and we need the knowledge from the developers and making judgment decisions on
yes,
how many parameters, etc. So here we have of the order of a few hundred types. Right, most of them are syntactic, and then these are the types of data packlets. And so the lists is something very important as usual. And so this is where the structure goes deeper. So this is what we have here.
Very nice. Okay.
So this is one project. A second project is captions. And here what I did, and you see I have to review it for every version, is to separate. This is a partition of all the 7,000 plus symbols into right now 203 different areas. And so this is, I don't know, we can take associations. So here there will be all the association symbols. And I did this in order to simplify the translations into Spanish. So it's easier to translate a bunch of related symbols, because you can make the same decision on how to translate individual.
So this is a question of bucketing. I mean, does Wolfram language data know about the things that you have?
Yes.
So this is here. So there is some sort of graphs. So these are graphs of the areas and sub-areas, etc. I have a tree here, which shows it better. And so these are the sub-areas, right? So there are the 203 areas. And so you can do something like this. Yeah. Give me all the date symbols, and it will give you.
Sorry, is the hierarchy represented in Wolfram language data, or only the leaves?
I think there is no hierarchical structure, but you can ask for the language symbols or the tree symbols or code symbols.
Because when I was just looking a minute ago, it looked like the functionality areas, when you take all the symbols and you ask for the functionality areas, it always gives you a list of length 0 or 1.
I see. So what you're suggesting, Christopher, is that given a leaf like comparison operator or something, or given a thing which is a leaf from comparison operator, that it give you in some way the path back to the root of Jose's tree here. Is that right?
Sure, something like that would be nice. Yeah, I mean, I'm just wondering, because I was also, in terms of my annotating types as re-implementing or whatever, I think that the next phase of that I should do it for a particular area, so it's useful to get these.
Pretty useful, yeah.
Right. Okay. So, this is also quite wonderful, Jose. Yep.
So this, and this is updated, and all symbols, all system symbols are in one of these categories. And so the third thing I wanted to mention is that I had started. This is back 2017, a similar project to what we are discussing today. And so I started alphabetically. So I have the audio symbols here as an example. So the idea, this is my own notation. So it would be one of these is essentially one of the entries in the definition box. And so you see here, for example, that I have things like frequency ratio. So this is a real number, but I'm actually giving it semantic meaning. So this is the thing that was trying to imitate what we do in the predictive interface. Yes, and so, then
it's as if it's a type hint that in addition to the raw sort of functional compiler type, it is also describing something about the semantic purpose of that.
Right.
That piece of
exactly.
data.
But I think if you are going to be, for example, something that would be very useful would be to say, give me 100 random expressions of this type, and we feed one of these types. And if it's a list of contexts, because you want to test one of the context functions, it better be real contexts, not just random symbols, random strings.
I also think the code assistance system could really benefit from having semantic annotation as well. If we know the semantic annotation, why not give it? I mean, if we know that that list, although I don't think we want to multiply the internal types to have, a DMS list as well as an ordinary list vector.
Well, this is a project that can be done in iterations in which we go deeper. So perhaps we start with the first initial level here. And so, so for example, audio split would take a list of audios and a time, and would return a homogeneous list of audios.
Yes.
Out of curiosity, what is the because I see you have a function type, which represents the inputs and outputs. What is the type that's just quotes function? Is that like a generic function type or what?
I'm not sure I got to that. So as I said, this is just the beginning. I may have a few hundred symbols out of the 7,000. So I have at the beginning here, like, let's see. So yes, so these are the definitions of the things I have been using there. So a duration, for example, it can be a positive real or a quantity. And the audio types, audio models. So
nice,
So this is something that requires us in the predictive interface. It requires work from the actual developers, the developers who can make the judgment calls of what is important, what should be nice to preserve, etc. So the same thing happened in the predictive interface. I wrote several thousand button rules here for the simpler things, but then at some point I had to continuously contact the developers of various areas.
So parts of this also remind me of, I'm not sure if you're familiar with Clojure, is this thing called spec, which for a long time I've been meaning to implement a version of in Mathematica, but this looks a bit similar to that actually.
I don't know it.
But yeah, that's fine.
Well, it seems to me that maybe Christopher could work with Jose to basically try and make a sort of master template for representing.
These are very similar to compiler types.
I know, which is why we want to make a master template, which we can then deploy for all of these purposes.
Well, what do you mean by master template? I mean, you just mean like
given a function,
syntax like this for writing out.
Yes. Yeah, sure. Given a function that it can then be deployed as, this is how the predictive interface is going to use it, this is how the translation team is going to use it, this is how the compiler annotation system is going to work, and so on. With a single, because I mean, I think what Jose is showing here is that basically the workflow for the person doing this annotation is you go to the usage message and you, and probably you do it for a gaggle of functions at a time, just like for the translation thing. And then you go to the usage message and you start annotating, start giving the annotations.
Right.
And
perhaps we should take an area and consider it an example. It would be good to have an area that other developers.
I would argue graphs. I think list manipulation is two. I mean, one, a lot of it's already supported, and two, it's
right.
one of the most.
Graphs sound like a good one. Yeah. Sounds like a good one. And then in the end, what one would expect is that this type of material would basically go into documentation pages or something, or some parallel system. Where do you think we put this in the end?
I think so. It should be like we use the syntax information, which is in the ref pages.
Yeah. So this would be another thing like that.
Why wouldn't it be in documentation?
That's what we're saying, Tom. That's what we just said. Put it in documentation.
Not a parallel thing.
Yeah, okay, right, fine. But I mean, and then the other question is whether we would expose a user level version of this.
I mean, we already exposed some of it because we have a type of. So type of lets you, I mean, this is a documented function that lets you give it a piece of code and it tells you what the compiler thinks it.
Whether one of the things we should imagine is that this is a structured piece of documentation that you can actually see, what as something in in kind of documentation visible style. I'm not sure. I mean, it might be useful.
Maybe just
yeah.
Well, I was just going to ask. I mean, so for the predictive interface, for example, what is sort of the format that it needs types in? I mean, it just needs to know for each function, like for each head, basically, and for each object, what the type is, or?
So in the predictive interface, we typically use just strings. And the idea with the predictive interface is that given the previous output gets associated a type, and that determines what are going to be the next suggestions. That's why it's important that, for example, if we look at both the input and the output, and if we know that a list of integers came from date list, then we mark it as a date, because that makes the next suggestions to be more
right.
I see. And what if I mean, what about cases where it kind of fails, or like if you chain multiple functions together and it doesn't know what to do with it?
Well, sometimes by construction, we decide not to assign any type. There are things that appear so frequently, like 0 or 1, true, that we just don't offer anything. We don't assign any type.
Right.
But this is a particular feature of the predictive interface that for super frequent things, we didn't want to overwhelm the user with always the same suggestion.
Sure. But I just mean, like, if you had, for example, I don't know, if you call what's called generate audio, and then you give it a net chain object, right?
Hey,
I mean,
I really need to exit, but you guys can continue and should continue.
Well, I think we should think about another meeting. Actually, would be more.
I know, but you guys are on a roll here, but I'm just really late for something else, so I'm going to disappear. But I think you should continue the discussion of this particular topic, just to try and define, so that we can actually get going on having the master annotation structure and then start annotating something, right? And make sure that it can land in all these different places. Right, anyway, I'm going to disappear, but this is a lot of very nice stuff and very important stuff. Okay, disappearing. See you guys soon.
Right. Bye.
Bye.
Yeah. So I guess. Yeah. Go ahead.
I was going to say that, for example, for very recent objects that we don't have yet in the predictive interface type system, we just don't offer anything.
Right, but I mean, even apart from stuff we don't support, I'm just asking, like, for example, if you, I saw, you have various function types where it says this is the input types and these would be the expected output types. But what happens if if someone just has an error in their code and they write something that's just incoherent from the perspective of the types in here?
Are you talking about this side there, or the predictive interface?
I meant the side on the right.
On the right, yeah. So this is very much underdeveloped. I haven't thought completely about what to do in wrong cases or for many scenarios. As I said, I basically just started alphabetically here with some family of audio, so I cannot answer. In the predictive interface, we have some rules prepared for cases in which there are errors. And so we try to help you based on the error that was emitted.
I see. And so for the predictive interface, it's really not doing any inferencing. It's just saying these are symbols that appeared in your code. Is that right?
Exactly. Yeah.
Okay.
Yeah. It's all based on the structure of the input and the output.
But it's not actually going to figure out that, oh, hey, does it actually like do inferencing where it figures out, well, this returns this type, and then that means that this next function will return this type, and so on? Or does it say, you're using a graph function, I'll make a graph recommendation?
Yes, it's generally based on type. The second thing you said, it just tries sometimes to be a bit more intelligent and says, oh, you used this input, for example, so I'm not going to suggest you precisely that function, or you used a graph of this type, so I'm going to increase the rank of this other function which is related, things like that.
I see. Okay. Makes sense. Yeah. Well, I mean, it's useful if nothing else, just to understand what, right. I mean, if there were some kind of grand unification of these type things, what are kind of the inputs and outputs that each of these different usages needs.
Mm-hmm.
But
so I think we should try to first decide the level of complexity that we want to go here, to prepare something that is not very complex, as we were discussing before, and then that can be extended if needed for some area. And then after we have these, then we reconsider whether it's useful in some of the other projects which are already working.
Yeah, I think that makes sense. Sounds good. Well, I guess, do we have anything else that we should go over? Tom, did you have anything else that you want to talk about? Tom? Oh, maybe you lost him. Okay.
Mm-hmm.
All right. Well,
Okay.
Yeah, sounds good then. Yeah.
Okay, let's stop here. And yes, you and I can meet, Christopher, and we develop this a bit more.
Sure. Yeah, and it would be interesting, if nothing else, to see the thing you had just annotating the audio examples. I mean, even if it's not real, so to speak, like it's right. I mean, because again, I tried to do something similar with graphs using the compiler type system, and it was definitely like, I mean, part of the problem is just that the compiler type system is a bit more restrictive than that, especially with like unions and stuff like, union types. And so it kind of makes a lot of those things a bit more complicated. But yeah, I think it's very useful just to do concrete areas.
Exactly. Yep.
Yeah. Sounds good.
Okay.
All right. Well, bye-bye, everyone.